My name is Valerie, and I'm here with Javier, a colleague. We're both working at Roche, and we wanted to present you a new package that we developed called descem, which will be used to, it provides a set of functions that basically facilitate the implementation of discrete event simulation in R. Oops. Okay, and just to give a bit of a background, so why did we even want to develop that? So we noticed that for HTA submissions, usually the default is to go with certain types of models, so area under the curve and Markov models. At the same time, however, we also saw that discrete event simulation could be increasingly relevant when we think about more complex diseases with heterogeneous populations, more complex treatment pathways, and so on. And one of the key barriers we saw was that it could be difficult for modelers to approach this in R. So we had a look at existing packages for discrete event simulation, but noticed that a lot of those did not have a focus on health economic evaluations. And also some of those required some more advanced knowledge, sometimes also in a different coding language. So for this package, we wanted to focus on cost effectiveness modeling. So basically comparing interventions and with life years, QALYs, costs, and ICERs as the key outcomes. And our target audience when we were thinking about developing this package was industry, potentially also HTA bodies that could, if we decide to submit a discrete event simulation for HTA, they could check that. And in terms of the level of experience, we are looking at intermediate R users, perhaps also beginners if they have some understanding of R. Also, in terms of the content of the package, we wanted this to be user-friendly, so put a focus on clarity and accessibility. We wanted it to be easily adaptable because this is one of the requirements that we would need to adapt this to many different countries. And capacity constraints were less relevant for us. We usually don't include those in cost effectiveness modeling, so this is not part of this package. So just to give a high-level explanation on discrete event simulation for those that are not very familiar with this methodology. So basically, this is a method that simulates a disease as a series of events that are happening over time. So events could, for example, be treatment discontinuation or disease progression. And within the simulation, the model clock is progressing in discrete time intervals at the times that the events are predicted to happen. This is a patient-level simulation, so patients are modeled independently, and they can also be given their own baseline characteristics, which then may impact the disease progression or the pathway through the disease. And so we have a little schematic here. This is just a hypothetical example of 3 patients that may have different experiences in going through the disease. And yeah, so we can see that discrete event simulation can model these different pathways individually for each of the patients. So jumping into our package descem, we wanted to give a quick overview over the steps that are needed to run the model, but we will go later into more detail on the specific functions. So at the beginning, the user, of course, needs to define what are the parameters. So the variables and inputs that will be needed later in the calculations of the simulation. And we identified 3 big buckets of parameters. So the first one are those that are common within the simulation across all of the patients. So for example, if you think about unit costs, those do not change depending on the patient. The second one is those parameters that are common for a patient across different interventions. And an example would be patient characteristics such as age and sex. So those would be different across different patients, but they don't differ across the interventions. And then those parameters that are unique to patients and their specific interventions. And an example here could be any kind of helper flags, so variables that may indicate or record whether an event happened during the simulation. So after defining those parameters, the user needs to also define the events that can occur during the simulation and also the initial time to those events. So these can change later, but an initial time needs to be defined. And after that, for each of the events, the user also needs to declare what actually is happening at that event. So what kind of calculations or changes to parameters and inputs happen when an event occurs, and we call those reactions. One feature that we also added, which is also specific to cost effectiveness modeling, is that the user can define utilities and costs specific to those events. But this is optional. So in principle, the simulation can also run without defining those utilities and costs. And then it would be a simple clinical simulation. And of course, the final step is to run the model and check the results. So now looking into what happens behind the curtains, the model engine, we are looking at 4 nested loops. So the most outer loop would be the simulation, for example, for probabilistic sensitivity analysis. And in this loop, the parameters are set up that are common to all patients. The next loop is the patient loop. And here the model sets up the parameters that are common for a single patient across different interventions. Then there's the intervention loop. So here the parameters are set up that are unique to each patient and intervention. Also in this loop, the initial event times are initialized and the model runs through the events as they are predicted. And then the final most inner loop is the event loop. So here we are looking at all of the reactions that are being executed, for example, modifications to certain parameters, modifications or updates to event times that are influenced by the event currently happening, and so on. And also within this loop, the costs, discounted costs and QALYs are calculated, which are calculated based on the current event and the previous event that happened. And since this is a cost effectiveness analysis, we are cloning each of the patients for all of the simulations that are simulated, simply to allow a fair comparison. So that means the baseline characteristics for the patients would be the same, irrespective of which hypothetical intervention he or she would receive. So with that, I'm handing over to Javier.
Sure. Thank you a lot. So as Valerie was mentioning, we need to set up certain inputs in order to run the model. And so one of these are, of course, the parameters. And while I will not go specifically on detail over every function, I think it's worth it mentioning what are the features that our package implements to make this what we claim to be readable or accessible for the user. So one of these features, for example, here you have how we add parameters, is lazy evaluation. That means that when you set up the value of a parameter, is not executed immediately, but is rather executed or evaluated when the model is run. That means that you can set up your parameters dynamically. So based on, for example, what loop you're running or what intervention you're running during your loop, you can set the value of one parameter to 1 or to 0, for example. That also means that you can implement external data that can be introduced directly calling, for example, a data frame, or also setting it as one of the parameters, because these do not need to be like a number. This can also be a list or a data frame or whatever. So we are giving you flexibility. after setting these parameters, you can, of course, need to set up what are the initial time to events that you will have, and also the reaction to those events. Here you have two examples, but rather than going over them on detail, I would just say that we have some features that I think are relevant. One is that we are using pipes, like in dplyr, so that it's easier to read. So for example, in this case, you can pipe different interventions. So you have the time to events of 2 different interventions, which makes it easier to read. And also you can also pipe reaction to events. So for each event, you have a function which are different with a specific reaction. And actually, in this sense, in order to specify what is the reaction to each event, we have helper functions that allow you and also the reader to understand what are you actually doing, what item are you modifying, what event are you modifying or creating. And not only that, but also we are using expressions. That means that you can write your code with full flexibility as if you were writing within normal R, but actually within each of the functions. And that means that it's much more easier to read, and you can also create intermediate objects that are also like make your life easier when coding. And debugging, and I think this addresses also a comment that was mentioned before, you can always debug through introducing browser in one of these code chunks, and that means that you can also verify the values while you are actually running the code, which means it's much easier also to validate the values that you're using. Next, yeah, thank you. As Valerie was mentioning, utilities and costs are optional. And so I will not spend a lot of time here. I would just say that we have several types of utilities and costs that you can implement, and of course they will discount it. And what's important here is that when you're defining the utilities of the cost, you can actually define them in this symbolic manner rather than just plugging in numbers. And this means that it's also easier to read, under which circumstance would one type of utility apply, under which circumstance would another type of utility apply. And again, if you are curious about what value we would actually take, you can always browse and debug it while you're actually running the code. And finally, once you have the parameters, you have your initial events, your reactions to these events, that is what happens when you reach each event, and also your utilities and costs, even though these are optional. Then you plug all of this into our runsim function, along with other parameters like the number of patients or the number of simulations and the discount rates. And of course, you can also implement the PSA. So for example, this is just another variable. So that means that you can always configure your parameters based on this variable. And on top of this, you are using parallel computing to make running times manageable. We are not claiming that it would be as fast as running this through C++, but again, that was not our objective. Even though this is a very recent package, so we expect efficiency gains in the future as we improve on our code. Of course, once you have run the package, you have a certain output that is easy to read. So you have, of course, here an example with all the events that you would have once you run the simulation with event time, the discounted cost, qualities, live years, and other variables. You can also export any kind of parameter or variable that you have created in between. So that means that we are giving also the user flexibility in terms of what you want to export. And so once you have run the package now, in terms of one reflection that we have after we have developed this package is one that in developing it, because we wanted to make it easier, or let's say for intermediate or almost beginner users, we wanted to have these feedback sessions in which basically we develop code independently, and then we met and we tried to talk and discuss what would be the most intuitive way of doing things, etc. And so because we wanted to focus on this clarity, it meant that we had to understand what is the added value of our package versus the others. And that was accessibility. That means that when someone has to validate that code, that is easy to read. That means that when someone has to write that code, that is also easy to understand or intuitive to understand what you're doing. And of course, in that sense, we also wanted to give full flexibility in model design, so we won't want to restrict in terms of the inputs that the user has to provide. And that meant, for example, allowing for numeric, character, lists, matrices. And also you can, of course, even run a Markov model if you set it up properly. In terms of speed, of course, this means that because we are using this flexible evaluation, it means that it's going to be slower than using, for example, only C++. But again, that was not the focus of this project. And again, profiling can also help in terms of optimizing the code. And just to conclude, the question is, why would you use descem over other packages? Well, first is without capacity constraints for cost effectiveness analysis, okay, with a focus in terms of accessibility and adaptability. And in this sense, descem can be a good solution if you are a modeler that you want flexibility in what your disease modeling, in what you're doing. You want clarity in your code because sometimes other packages, because they don't have this focus on cost effectiveness analysis, can be harder to read or can be harder to validate. And it also facilitates discussions and adaptations, which in our case, because we're working with many countries, is sort of very important for us. Again, this is only in the first steps. This is still, it's in development, but it's ready to use. And we are looking for feedback and ideas. And we want this to be community driven because we want this to be accepted widely so that it can actually be used for proper submissions, for example. We have features that we want to implement, such as, for example, efficiency gains, of course, also more informative diagnostics and errors and warnings and other tools that could be useful for cost effectiveness analysis. And again, in long term, the idea is to have sort of an acceptance of the package that is validated, that the people understand what's doing in the engine, so that the discussions, can reduce the burden in terms of let's validate this engine, and instead let's discuss, what are the assumptions that you're making in terms of your model, what sort of inputs are you using, etc. So that was sort of our goal in the long run.